Greetings, we're from Group 21 and we'll be presenting the automated granulated paste filling machine. Hi, my name is Lo Jia Cheng and I'm from Chemical Engineering.
Hello, my name is Esther Rebecca and I'm from Chemical Engineering.
Hello, my name is Sanjay Devendran and I am from Mechanical Engineering Department.
Assalamualaikum and hi. My name is Muhammad Zarif Nazmi Bizaki and I'm from Electrical Electronics Engineering.
My name is Supinya Anak Perempuan Tawun and I'm from Chemical Engineering Department.
An interview has been conducted with Mr. Anas, the owner of a solar producing company, to understand the problem. He mentioned that the filling machine that is used will clog when it comes to the solar paste mixed with food granules. So when the machine starts, the worker must clean the machine and fill up the food granules manually, which will result in a lot of waste and ineffective production. Next, the machine cannot discharge even and consistent content due to ineffective mixing. Being consistent for each production is very important to ensure the product quality and integrity of the company. Therefore, to achieve the 12th SDG, that is to be responsible for consumption and the production of the resources, we have to find ways to reduce the food waste during and after the production. So the objectives are to design and modify a filling machine that is functional, which can discharge granulated paste smoothly without clogging itself. Then we have to ensure even and consistent content are discharged, and the price must be affordable to the SMEs.
SME stands for Small and Medium Enterprises, and as stated by the Department of Statistics Malaysia, the services sector comprises a total of 90% of all the SMEs, followed by the manufacturing, agriculture, construction, and mining and quarrying sector. Majority of the companies in SMEs have not utilized the advanced technology yet in their production. According to the statistics showed, one of the main reasons is due to the financial burden, as the advanced machines are expensive for them. In our project, we are targeting mainly onto the manufacturing sector, where the food production is included in this sector. During the process of completing our project, we have applied the design thinking tools that consist of several components. First is emphasized by identifying the problems faced by our targeted user through interview and online surveys. Next is defined by defining the problem statement that lead us to the objectives of our innovation. Furthermore, ideas allow us to find the best materials and suitable design concept. Followed by prototype by utilizing several applications to create the 3D designs for the machine and circuit simulation. Lastly is by testing the prototype through feasibility analysis to model the moving parts of the machine. With this step, we had finalized the design concept of the machine to solve the problems faced by SMEs employees.
Starting from the top, we have a motor connected to the mixer. Obviously, the motor rotates the connected ribbon mixer to ensure the homogeneous mixing of the substance. Next, the bowl is used to store the food materials for the mixing process. Moving on, the rotary valve is encased inside a valve case. The most special feature of this rotary valve is that it has sharp blades aligned in the inner circumference of the valve to help cut granulated particles that get stuck between the motion. Next, the nozzle is designed with a wider diameter to prevent the food particles from clogging the mouth of the nozzle. And an ultrasonic sensor is placed in front of the nozzle to detect the presence of container before dispensing the paste into the container. Now, the slider crank mechanism is used to guide the rotation motion of the rotary valve. While the e-stop button is a safety feature included to prevent accidents from occurring, this will cut off power to the circuit and stop the machine. The pneumatic piston is used for controlling the volume of the mixture that discharges out. The volume of the piston is adjustable according to the volume of the filling container. The control panel is placed to enable the user to dispense the paste manually. Now, for the machine mechanism, at start, the granulated liquid is poured into the bowl and mixed by the mixer with the help of the motor. Then, once the mixture is mixed, the pneumatic piston undergoes in-stroke motion to pull the granulated liquid from the bowl to the piston. Once the pneumatic piston reaches its maximum inward stroke and all the granulated liquid has filled up the piston's compartment, the rotary valve turns 90 degrees and the granulates between the valve's opening is cut by the blades in the valve to prevent clogging. Now, the rotary valve has turned 90 degrees to facilitate the movement of granulate liquid mixture from the piston to the nozzle. Then, the compressed air pushes the piston into the outward stroke motion, which then pushes the granulated liquid mixture out. The mixture is pushed towards the nozzle through the valve, which then fills up the containers. Then, once the valve and the piston is empty, the rotary valve returns to its original position and the process is repeated. With that, let us proceed with the methodology part of the presentation.
To calculate the amount of maximum container that can be filled within this machine, we have used a mathematical model from mass balance equation to derive an equation as shown here. From the equation, N is the number of filling container, AB is the cross-sectional area of the bowl, H is the height of the container, and VP is the volume of the piston. So based on our bowl dimension of 30,000 cm3, for the conventional 220 cm3 sambal jar, our machine can fill as much as 136 container per bowl. Next, for power consumption, this machine uses three main electrical components, which are agitator, relay, and solenoid valve. From the datasheet of each components, we obtain the individual power consumption, which are 370 watt for agitator, 1.5 watt for relay, and 4.8 watt for solenoid valve. Assuming the machine operates for 5 hours per day, 20 times per hour, the estimated power consumption for this machine is 37.63 kWh only, which will only consume Rm8.20 of your money in monthly electric bills. For the material selection, three main materials we use are stainless steel, super hydrophobic materials, and silicone rubber. Stainless steel has high heat tolerance and chemically inert. It is also can be cleaned easily, that make it very suitable to be used in food industry. Next, super hydrophobic material is used for coating purposes to create a non-sticky condition to prevent the granule material stuck inside the machine. Lastly, silicone rubber is used for on-off button and control button because it is an excellent electric insulator, which makes it safe to be used with high current device. From the chart, it can be seen that the tasks are well distributed among the team members and everyone collaborates well to produce a well-rounded result without having anyone left behind.
Firstly, an interview has been conducted and we brainstorm for the ideas and problem statements to finalize the objectives of the project. Next, we begin to design models, prepare and submit the extended proposal. Follow that, we prepared for the animation and the 3D design of the models. In the meantime, we create ideas for posters and videos and distributed our tasks for the final report. In week 9 to week 11, we added the poster and video for the presentation in week 12. Lastly, in week 11 and week 12, we finalized the poster, videos, and the final report for the submission. Moreover, we prepared for the ETPX session 2. From the calculation, the total cost of the machine is approximately Rm4,000 that comprises of material cost of Rm2.427k, manufacturing cost of Rm1,000, and servicing and maintenance cost of Rm200. According to the SMEs Corporation Malaysia, the sales turnover of SMEs range between Rm300,000 to Rm50 million. Hence, with the cost of Rm4,000, the industry would have 75 times of return, which is a fair bargain. From the survey, 98% of the respondents think that the cost is affordable and the machine is highly feasible to be applied. Furthermore, all of the respondents think that it has a high market value. However, for the HSE analysis, only 62% think that it is highly emphasized, leaving with 36% and 18% feels that it is moderately and rarely emphasized.
In conclusion, rotary valve and bigger nozzles can ensure smooth flow and prevent clogging. Next, conical ribbon mixer can ensure even mixing and consistent discharge. Lastly, the price range of the machine is affordable as shown in the economical analysis and surveys. However, recommendations such as more safety features can be added to the machine to reduce the risk of the accidents. Then, larger bowls and volume can be made to have more containers filled. And lastly, more energy-saving components can be used to save the operational cost. In all, it can be concluded that all objectives are achieved and this project design is feasible.